Good morning, everyone. This is Venkat from Genetics, Coimbatore. On behalf of Genetics and Phamic Technologies, I extend a warm welcome to all for our Automation Studio webinar series. So, Genetics is proud to be an Indian manufacturer of automation products, providing innovative solutions for various industries and offering didactic systems for technical education. So, we established in 1977, and our R&D division is approved by the DSIR, and we boast an in-house tool room facility for tool and die machinery. As an integrated manufacturing system certified company, we have a pan-India facility service with over 15 branches across the country and 4 overseas offices in the USA, Germany, Africa, and Dubai. Our global presence includes 300 plus support engineers and 150 plus dealers and stockists, serving over 1,000 OEMs and 17,000 plus direct customers. We are also the authorized distributor of Automation Studio in India, and we are excited to have Ms. Kalyani from Phamic Technology with us today to lead the session. We have a series of webinars planned on various topics throughout this month. If you have any questions, please feel free to write them in the chat box, and we will ensure they're addressed. Now I invite Ms. Kalyani to begin the session. Thank you.
Okay. Good morning, everyone. I'm Kalyani from Phamic Technology. So this is a webinar on the analysis of aeronautic electrical circuit design in the Automation Studio with the upgraded version 9. So the topic covered will be overview of aeronautic library, avionics fundamental example, then block diagram, and at the last we will see for the question and answer. And if you have any question in between, you can use a question panel to put your question so we can address it during the session or after the session. Okay, so before that I will likely to brief about our company. So we founded in 1986. We are ISO 9001 to 2015 certified. We have 130 engineers and software specialists. We known as the industry leader by designing the world-class trade-oriented tools in the field of fluid power, electrical engineering, industrial automation, and custom software development. We have 3 offices. Our headquarter in the Montreal, Canada, second one in the Germany, and the third one in the Pune, India. We have in-house expertise in the field of software development, engineering, and industrial automation. So in the field of software development, we have software engineering, database design, network support, multimedia application, real-time systems. In the field of engineering, we have CAD, CAE systems, pneumatic system, hydraulic, mathematical modeling, electrical, automation engineering, instrumentation and process control, and training. In the industrial automation, we have PLC programming, SCADA system, human machine interface, electrical control, process simulation, system maintenance, and the robotics. We have 4 products. The first product is the Automation Studio Professional Edition with the version 9, which is used to create, analyze, troubleshoot, and validate multi-technology circuits. Automation Studio Educational Edition, which is used to train the future technicians, engineers on the hydraulic, pneumatic, electrical, robotics, process control, and PLC system through a simulation. In Automation Studio, Live Manifold is used to complete the hydraulic system manifold software solution for design, coding, and the prototyping. And the last one is the Unknown Studio, which is used for the Industry 4.0. Our objectives are to provide a long-term relationship, effective support by phone, email, or online. We have dedicated representative for each account, and also we provide a support material like training videos, demonstration file, quick start guides. Today's agenda is to see the Automation Studio Educational Edition. So we will see it after this one. We have we have some milestone like in 1986 we started. In 1989 we are DOS based HydroSim and NeoSim. From that in 1996 we have Automation Studio version 1, and from that we are continuously upgrading the software, and we are fulfilling the customer requirement until the date we are in the Automation Studio version 9. So Automation Studio is a multi-user collaboration sharing tool. which is used for the simulation animation, machine documentation, trade-oriented system design. So you can see that in this structure, we fit in the multiple program like electrical control, electrotechnical, mechanical, hydraulic, pneumatic, as well as different programming language like PLC, block diagram logic, as well as SFC logic. Our key benefits are for the students, teachers, and the schools are like for the students, which is used to validate the theories studied in the class, as well as illustrate the system behavior dynamically in a full color, reinforces the understanding of the system interactions, and allows to virtually test all types of system. For the teachers, which is used to facilitate the demonstration of system interaction, enhances teaching and learning by working on virtual system, easily integrates into the course of content, and can be easily handled by both teachers and the students. For the schools and universities, which is used to eliminate the need to purchase the single technology software, can be used in conjunction with the other department, limit the purchase of expensive and often inaccessible hardware, trains the student on leading edge tools commonly used in the industry. We provide the remote access so that student or the teachers can access it from the school or from home, as well as we create the priorities for teachers and the students and configure the time restriction and access points. As per the international presence, we available in the 13 languages and we sold over than 150 countries, which is used in the high school, career centers, college, universities, and workforce development. Here you can see that the automation studio provide you the different example which is already created by following some publication books. So here these are the publication books for example, and this is the example from the fluid power with applications by Anthony. This example is created by taking point into consideration from that book, so student can directly use this circuit just to analyze the things so that they can create their own circuit like this one. As well as automation studio has some interactive exercises so student and teachers can access it. Automation studio provide you the digital twin of your own equipment via the OPC server client, so the same circuit, same hardware kit can be reflected in the software. So you can see this is the example for that one. Automation studio have a different illustrated libraries. So in the first, here you can see the illustrated library for PLC, illustrated library for AC, DC and motor control for the pneumatic as well as hydraulic. So that particular components will belongs to that category. Uh, we have three ways to create, simulate and troubleshoot the circuit, like by using the symbols, by using the illustrated components which are available in the illustrated library, and by using the virtual trainers which are available in the virtual trainer kits. There is a key benefit of automation studio. So here you can see this is the example from the automation studio by using the virtual trainer, and this is a hardware kit. So I will just start this video. It is just a 1 minute video, so you just compare the things. So in the right side, the connection is as per the automation studio software, and at the left side it is on the hardware kit. So the same things can be reflected in the automation studio. So we have that type of components and we can use it directly on the project. Okay. So this video, I think you have given us a short idea about the automation studio. So as per the benefit point of view, if we have only hardware, only 2 students per unit can work on the hardware. But if you have hardware plus automation studio with the 2 hydraulic or electrotechnical hydraulic trainer kits, 20 users can do the also practicals. So it is less expensive option than the hardware. Then Automation Studio provides us the most important features like a manufacturer catalog. So this is the list of manufacturer catalog like Uken, Booker Hydraulics, Bimba. So which can be accessed through a web or by using the online catalogs. So in these catalogs, the components from that manufacturer will be there. So it is as per the website, the component will be available. So this is the example, like by taking the one of the component from manufacturer catalog, this is the circuit which is created by using that component. And again for each and every component, this is the web catalog. So from online catalog screenshot. So from this you can see you have the example as well as PRX just to demonstrate that type of circuit. Here is the partial list of industrial clients. So here in the field of aerospace, we have Airbus, NASA. In the field of agriculture, we have AGCO, John Deere. In the field of energy, we have ABB, Orano. In the field of forest, AGCO, John Deere. In the field of construction, Caterpillar. In the field of defense, Larsen and Turbo. In the field of meteorology, China Steel. In the field of mining, Epiroc. So for the offers, transport, system integrators and handling, this is the partial list of our customer. So now we will move to our main agenda, like overview of aeronautic library, avionics fundamental example, block diagram, and at the last question and answer. So if you have any question in between, you can just put your question in the question panel. So now I will move to the window of automation studio. Yeah. So on the screen, I have shared the automation studio. So this is the interface of automation studio. So at the top, you can see this is a ribbon bar where we have different tabs like home, edit, view, simulation, system analysis, electrotechnical tools, and this is the student tab. Again, in the students tab, there are different means it is the conjunction with the different tabs which is mostly used tabs actually. So whatever the tabs student can need, they can access it from here. They don't need to go in each and every tab. So in the home tab, you have the features like library explorer, catalog manager, online catalog. Again, if we are using the electrotechnical project, so we have the wire option. So these are the different types of wire like polyphase wire, ground wire. Then we can change the snap functionality and different drawing tools. In the edit tab, we have different editing option. In the view tab, we have different viewing option like a new view, vertical tide, then navigation. In the simulation tab, the features regarding to the simulation like slow simulation, step-by-step simulation. Again, some dynamic measuring instruments are available in the simulation tab. Troubleshooting tools are also there. Like you can see here, we have oscilloscope, multimeter clamp. So this is the same instrument as we are using in the laboratories, and that is working on the same functionality. In the field of electrotechnical, so if we are using electrotechnical or aeronautic project, so we have this extra window which is used for the wire and cable spool builder, cable builder. So if anything regarding to the builders for the wire configuration or the connector configuration, as well as for the PLC configuration, you can use it from here. So at the left side, we have the library explorer. So we have hydraulic. So it is depends on the different technologies like hydraulic. As Automation Studio is a multi-technology software. So in the library also we have multi-technologies like hydraulic, pneumatic, then proportional pneumatic, drive and transmission, electrical, then digital electronics, ladder. So this is for the programming point of view. Then electrotechnical IEC blocks. This is again for the programming point of view. And then HMI and control panel. And in the version 9 only, we have one more extra technology like a robotics. So the component from the robotics will be available in this window. At the right side, we have the project explorer. So whatever the project is open, you can see here. If you want to open a new project, so you can just click on the new project and you can open it. Again, in the educational edition, we have some illustrated example. So if we want to use some of the illustrated components or illustrated template, like if you want to use some virtual system, so you can just go in the virtual system. So if we want to see for the Siemens, so these are the examples. So students or teachers can directly use this example to create their logic and just to have practice for this type of example. Then the we have the main focus is aeronautics. So the aeronautics library is available in the illustrated template. So you can see if you open on the orange icon, we have this electrical aeronautics. I just click on it. So the library for electrical aeronautics got open. So the electrical aeronautics is nothing but the components are compatible with the electrotechnical technology, but its features are compatible with the aeronautics. So if we go in the generic component library, we have this electrotechnical IEC and NEMA. So if I click on electrotechnical IEC, we have this structure like lines and connection, control, power, basic passive and active component, and black box. So the same structure is followed in the electrical aeronautics. So lines and connection, control, power, measuring instrument, and basic passive and active component. So again, if you go on any of the tree structure. Like if I go in the control, the components belongs to that category will be there. So in the control we have protection, switches, relay contacts. If I go in the power, so powering related component will be there, like energy sources, transformer. In the motors we have DC motor, three phase or synchronous motor. So in the DC motor again we have different types of DC motor, like a series wound, then separately excited, shunt wound. Then in the measuring instrument, these are the measuring instrument. And apart from this, in the simulation tab also we have this measuring instrument. So during the simulation, anyone can use this type of instrument. So to create any of the example, so we have to just drag and drop that particular component on this workspace. So I just create one example for the light controlling scenario. So for that, I will take one switch just to start and stop. Then from the sensors, we can give the name of the allies. So during the assignment also we can use it. So this component can be used in conjunction with the association of different components. So we can give the name give its allies, so that we can find it when we need to give an option for the variable assignment. So in the sensors, we have level sensor, pressure sensor, flow, temperature, speed and position, light, vacuum. So from that I choose pressure, and with the pressure I will use two position switch. So what I will do, I will create two scenarios just to like we can show up and down position of plane. So for that I will just move it vertically. Yeah, just connect it. Again, if you double click on any component, we have the property window. So this is the property window. In the data tab we will see the property for that component. So as it is a pressure sensor, it has some assigned pressure, and after this assigned pressure, the position of this NO and NC will change, interchange. Like so, I will connect some signaling devices. So in the signaling devices we have audio, we have light, and we have lamp. So from the light I will use panel light, and from the lamp I will take this fluorescent lamp. This is just a scenario, so we can just correlate with it with the aeronautic, like up and down position. So if it is up, so it will activate. If it is down, it will get activated. So as it is a pressure sensor, we need to assign some values. So what I will do, I will use some of the drive and transmission element from the generic component library, or we can use HMI control. From that I will use one control element for the set point. So I will use this vertical slider type, and I will give the name as a pressure, because I want this slider to give a pressure to this pressure sensor. And now if I double click on this component, in the variable assignment tab I will link this pressure with the pressure slider we have taken from the HMI library. So this is the component. So I directly get that component because I rename it with the pressure name. So here again you have the option for the unit. So these are the options. I just validate it so that this slider is now associated with this switch. Again, if you see here, the range is 100. So we need more than 100. So I change this range to more than 100. So maximum output signal, I change it to 200. So if I go more than 200, suppose I start the simulation, and now if I close it, nothing is happened because my pressure is at 100. But I change this pressure. Just sorry, I forgot to add a battery source. So I just add a battery from the power, sorry, from the aeronautic library, and from the power energy sources, I will take one battery. So this is a battery of 12 volt. I connect it positive to the positive and negative to the negative. So if I start the simulation, you can see this is the lamp which is getting activated because just a minute. So this is the same example. So if I start the simulation now and I close this switch, this is the second path is getting activated because my pressure is the 0, which is less than the assigned pressure. So this is the NC, and upper one is the yellow. So this fluorescent lamp is getting activated. But now I change the assigned pressure to more than 100. It should change the position, and you can see this is now activated, and this red lamp is getting activated, means it is showing the status of that signal. So we can see that if pressure is more, it means that my plane is at the up position, so this LED is giving me that status. And if my pressure is low, it is showing me the plane position as a down position. The same scenario is, we can correlate with that. So I have one example. I just show you that one is already created. Yeah, just a minute. So this is the interface, and this interface is created by using the HMI library, which is available in the generic component library. So from here, this is the interface created. So now I change the view to the vertical tile. So this is a vertical tile, so I can see two windows at a time. Change to the zoom all component. Yeah, so at the same time we will see the both windows. Now if I start the simulation, so this is the example which is which is showing us the status of the strobe, beacon and navigation lamp for this aeroplane. So now if I activate this strobe light, what it will do from the electrical control. So this is the circuit which is created by using the library of aeronautics. So this circuit is already created. So this is the relay contact which is activating the strobe, and as per that strobe, this lamp are getting blink, and the variable assignment is done as per that. So this lights of the plane will blink. So if I click on the strobe, you can see that my strobe light with the white LED are blinking. In the field, in case of beacon, this beacon path is activated same way in this beacon, and that is giving the status to my plane, and which is showing the red beacon light on the aeroplane. If I click on the navigation, it is giving it the navigation lamp is activated, and it is giving the status on the upside, that is green and red one at the left and right side. So this type of example can also be possible in the automation studio. I have one more example for the fuel system. So in that example, for the different tanks, fueling is done via the different, we can say the different toggle switches. So this is an example. So the controlling is done by using these switches, and this switches is taken from the HMI and control panel, and this the logic for this one is created by hydraulic library. So in the previous example, we have seen the same way is created in the from the electrical aeronautics library. So now if I start the simulation, it will give us some sound which is showing that my plane is some at some position, like in actual practice. So you can see that. And again, if I activate any of the switch, it will fuel that particular pump. So if I close this tank one, so it will give the fuel to that particular tank. So if I activate this tank 1, it is giving the status to this. So tank 1 is giving the fuel to this tank 1, 2 to the 2. So like this scenario are also possible in the automation studio. Then now we will see one more example for the which is created for avionics fundamental example. So which is in more deep. So in that the structure is created on the basis of avionics, and the logic is created by using the block logic. So I just open that file. Just a minute. So if you have any question, you can put your question in the chat panel. Yeah. So this is the fundamental example for aeronautics. So in this example, you can see that this interface is covering most of the point regarding to the aeronautics. So here the different battery charging or the pressure switches failure activation is also is also done. Here different controlling is done, and here we can adjust the speed and the attitude of the plane, and here it is giving us the animation of that plane. So for this to to operate this interface or to have the control to this interface, we need some of the behavior and the logic. So behavior is created by using the aeronautics library component from the aeronautics library from here. So this is already created example. So this is the circuit for landing gear control system with position indicating system. So with this behavior, for this interface we have indicated the positions, like whether it is at the down position, at the up position. So during the simulation we can see effect in which light or which led is giving us that particular status. So if it is in the takeoff position, it will give this indicator light. If it is at the up position, this lamp will get activate, or this led will show us the status. So this circuit is created for that logic only. Then this is a twin piston engine aircraft system. So there are two motors. So on the interface also we have these two motors, like left and right starter. So to have the speed control for this motor, we have this behavior logic, like a twin piston engine aircraft starting. So for the starting we need to give some speed higher than some particular value. So that higher value is indicated in the block logic. So when my system should operate with that way, or when my system should go at the up level, so for that we have block logic. We will see that one also. So in engineer anti-icing system we have different means on the interface we have this failure activation. So if heating is more than particular value, it will activate this heater. So for that, that is the operation, this is the behavior heating element. Then this is a battery charging. So if I want to charge my battery with the external power, so this is the external charging process, and this is the block diagram. So to have a control on the behavior or on the interface, we have the block logics. So Automation Studio provide you the different programming languages. So one of that from that is a block logic. Then we have SFC, sequential flowchart, and we have ladder logic also. So with the block logic, we can control the operation as per our need. So now on the interface, you can see, suppose this is my plane. So what I want, if my left and right starter speed is more than particular value, suppose for example, in this example, 2300 RPM is considered. So what are my scenario? Like my speed should be more than 2300 RPM, and again this ground toggle button should be at the air. So it should not be at the ground, so that this plane will go up, right? So or it will be ready to take off. Or so in the block logic, the same logic is created. Like you can see here, this is the variable assign. So in every block we have the variable assignment option. So we have did a variable assignment with the ground position. If it is not ground, and if angular speed of the motor, so this is the angular speed. If the angular speed of the motor is greater than, so this is the block for the greater than, is greater than 2300 RPM. So then my plane will be ready to take off. So this is giving us that status, or it is giving that control to the interface what I have. So for the block logic, in the generic component library we have the library for the blocks. So you can see here it is the blocks. In the blocks, again we have different components like input, output, connection element, mathematics, signal processing, logical operator, and the custom. So if anyone want to do custom component, they can also do by using this customizable component block. As well as we can embed the different components. Suppose this is my block logic. So if I want to embed it in a single block, that is also possible. So again in the inputs, the component for the input, like a sine wave generator, square wave generator. So it depends, it is solely depends on the logic what we want. So this is the ramp. So this ramp and random number generator is added in the version 9 only. In the outputs we have output variable, like here also we have output variable. So this is a connection element. So in the connection element we have selector or switches. Sometime we may want some selections or the switches, so that is also there in the blocks logic. In the mathematical, different manipulation operations can be possible. So we have matrix also. In the signal processing, the component related to the signal processings are available. In the filter we have filters, we can limit the bound, we have the threshold, we have the hysteresis. In the transformation we have Park transform, inverse Park transform. In the logical operator we have different gates, logic gates, we have comparator, truth tables, edge detectors, counters, timers, flip-flops. So we have different blocks actually. After this example, we will just create simple example by using these blocks also. So on the interface, now I start the simulation just to show you the effect. Okay, so if I start the simulation, now my battery is charged at the 90%. Suppose I use external charging, it will increase its charge percentage, right? So this is for the external charging. Again, at the same time, if suppose I want to see this behavior, now it is at internally it is getting means it is using the internal power. Suppose I use external charging process, so this interface will use the external charging process. So you can see this external power relay is now activated, but before that it was from the battery. So this relay was activated, but now it is this relay is getting activated. So how it is happening? Because in the behavior as well as in the block diagram, we have did the association with that fashion. I want to just see the effect on this plane. So now my plane is at the down position. So you can see I'm at the down position. So this green LED is showing me that status. I want to start the operation. So firstly, I need to activate the starter switch, right starter, to activate this right starter motor. So you can see this right motor is activated, but not this left one. So for that one, I need to activate the left starter switch also. I activated this left starter. So both motors are rotating. So the logic for this motor rotation is in the twin piston engine aircraft system. So you can see my motor is rotating at 1225 rpm, but on the logic we have given 2300 rpm. So just I will, yeah, you can see 2300 rpm. So when I'm more than 2300 rpm and I activated this up button, then I will be at takeoff position. So on the interface I will do this, I will follow the same steps. So during following the steps, we have to make sure that the operation is same in the block as well as in the behavior. So now next thing is I need to have the speed more than 2300 rpm. Again, I should activate this toggle switch to have the air. So you can see now my plane is at the top position. So it is ready it is in flight mode, or previously it was in the takeoff position. So now I will switch this to the up position. So what happened? It is in my plane is at the in transit position and it will close its wheel near to the plane. So it will just take some time. So you can see that wheels are getting close, and from in transit it will show the status like it is at the up position. Yeah, so it is now at the up position. So to follow the reverse step, we have to again follow that, which we must reduce the speed. We make need to give it to the down position so that wheels will get extracted, and then I need to have this air to the ground so that my plane will be come at the down position. So this is at the ground position. So during the simulation, you can activate any type of fault. Suppose I want generator failure, so that type of faults can also be activated. So again, so this is the just a simple this is the already created example, but apart from that we have the examples in the new project like I already shown you. So these are the different technologies. Suppose for the, we can see this is compatible with the electrical, so you can see the electrical, then virtual trainers. So these are the different examples. This is a relay logic, this is a VFD. So anyone can refer this example. Okay, so we just see for the yeah, for the for having the different diagram, we have this many of technologies. So now we just now want to elaborate for the block logic. So what I will do, I will take this block diagram, but apart from this I just as I explained, we have SFC and graph set as well as we have ladder for the programming. So I will take a block diagram. Yeah, so this is a block diagram logic. So from the from the blocks, we just take some different blocks to see the effect. Suppose I want to see for the flip-flop operation and for the edge triggering. So what I will do, from the input, I will take one square wave generator which has positive as well as negative values. So instead of this one, I will take this one. Okay. So you can see this is a square wave generator and maximum amplitude is 1. So instead of 1, I will give this 10. So what will happen? This square wave generator will give a square wave with the plus 10 or minus 10. Then in the logic, we have the edge detectors. So I have rising edge detectors as well as falling edge detectors. So as it is a square wave, it will go in the positive half cycle in the rising edge and it will come to the negative half cycle in the falling edge. So to give that signals, I just give this square wave generator output to the rising and falling edge detectors respectively. Now this is a short time actually. So to have the status of this, we need to use the flip flop. So we have this flip flops, SR flip flop D JK. So from that I will use this SR flip flop for rising edge detection, and again I will use this one for the falling edge detection. Okay, to have the reset command, I will use, if it is a falling edge it should reset, and it is a, if it is a rising edge it should, below one is reset. From the output we have output variable or this value display. For one I will use output variable, for other I will use display. So from the output variable I will, for every component we can show the value. Yeah. So now what I will do, I will start the simulation. So what happen, if I am at the positive cycle it will get 1. So you can see how this operation is taking. So this square wave is generating 0 to 10 volts. So what I need minus 10 to 10. Put signal, minimum amplitude should be minus 10. Okay. So now you can see how this operation is taking into consideration. And for the period or we have the selection mode also described by the frequency by period, and duty cycle is 0.5. So for every component we can just configure the value according to that component operation. Again we have the timer. So suppose I just delete this one and I will use one timer block. So from the timers I will use this timer in, and from the inputs I will just take one cursor suppose. So cursor is used to give an value during the simulation. So it is just type of pedal. So during the simulation we can vary this value from 0 to 10. And this is a PT. So for PT we need to give some value. PT is nothing but we need to describe the period from after how much time or how much second it should give me the status of the output. Again I will take one output, and from the input I will use one constant block, give the to indicate the time. So if you click on the timer we have this, yeah, elapsed time in the, I will give 3 seconds suppose, and here minimum value 5. So this 5 will, the after starting the simulation this 5 will transfer to this out block after 5 seconds. So after 3 seconds, yeah, so you can see after 3 seconds this one I'm getting the signal as a 1. So this is the example that how we can control the operation or how we can use the timer blocks or the different blocks can be used. So this is just a simple example. Now to have some different demonstration example from the for the blocks, I will go in the demonstration. From the by other modules we have block diagram examples. So from that I will choose any one of that. So integration, so this is for the robots, but robot is controlled or the 3D diagram is controlled by using the block logic. So and different drive and transmission element are also immersed with that file. Yeah, okay. So this is the example for forward kinematic simulation of spatial multi-degree of freedom robotics manipulator. So in this example, this is the 3D diagram. I just change the view, vertical tile, and okay, just adjust the screen. Okay, so this is a robot, and to have the control on this 3D diagram, this is the block logic where this drive and transmission elements are used. So these are nothing but the wheels. So you can see this 1, 2, 3, these are nothing but the wheels. So during the simulation, we can vary these links 1, 2, 3, which are linked to this joint, sorry, joint 1, 2, and 3. So how I vary accordingly, the position of this robot will be controlled. So everything is happening with the block logic. So if I start the simulation, if I vary this, so this is a steering wheel for joint 3, this is for joint 2, and this is for joint 1. Okay. So how I vary accordingly, this joint will get vary. So you can see if I vary this joint 3, this joint 3 is getting varying. Joint 2, for joint 2, this is varying as per now this one, and for joint 1 is moving. So you can see these are the equations. So according to this equation, or according to the block logic, everything can be controlled. So apart from this, if you have any question, you can put your question in the chat panel. So the topic for the today's agenda is done from my side. Sorry. So we have seen the aeronautics library example, block diagram, different scenarios for it. So if you have any question, you can put your question in the question panel.
Um, yeah, Kalyani. So thank you very much for the wonderful session. So if anybody has any question, you can just put the question in the question pane. Okay, so we can address them. Okay, so I cannot see any question. Okay, okay, there is one question from Mr. Shiva. How to make our own physical or mechanical system to make it work through PLC to make automation. Right.
Okay. So for this, we have the, just a minute. Yeah. So like here also, this is a mechanical system and this is a block logic. So how to make a physical or mechanical? Yeah. So for this one, we have OPC server. So via that, we can link software with the hardware. And if we want for this on the same project, so we have the variable assignment tab. So from that we can do. But with the physical, we have the OPC server.
So there is one next question from Mr. Chandrasekhar. Can we assign parts?
Mm, parts, can you elaborate something? Which type of parts? Can we assign parts?
Yeah, maybe we will type it. Mr. Chandrasekhar, if you want to open your mic and elaborate your question, so you can open your mic.
part numbers from OEMs. Yeah, for that one, yes. So actually, we have my screen is shared, right, Saurabh?
Yeah, yes, yes.
Yeah. So actually, we have online catalog, like I given you during the, yeah. So we have this many of catalogs. So if we want to see for the suppose electrotechnical, so we have this many of catalogs. Suppose I open a HIDAC, so we have this HIDAC, and as per part number point of view, we have this many of components or the series. Suppose you want, this is for example, suppose you want a pressure sensor for particular part number, so you can go in that catalog series for that particular manufacturer. Suppose you want this relative pressure, just a minute, it is getting open. So we have product configurator, so you can assign or you can see the part number from that one. Or in case if you that part number is not available, suppose this is the product configurator, so in SDA 4300 we have different component, so you can configure according to your need. But in case it is an OEM type of product, or which is not available in this catalog, so anyone can send us a request, means who purchase that can send us a request, and we can just provide as an on-demand service. So accordingly this component will change. Like here now the component is for current. Suppose I change the series for the voltage. So this is a different part number. Part number will also change and component will also change. So apart from this, if someone wants some new products which is not available in the online catalog or in the library explorer of Automation Studio, so for that we have on-demand request. So we can request us for the on-demand service. I think doubt is solved.
Yeah. So I cannot see more questions here.
Okay.
So yeah, if anybody has any more questions, so they can just type it in the question pen. Okay, so our next webinar will be on renewable energy. So you would have already received the registration link. Please register for the webinars. Okay. Okay. Venkat Prasad, are you there?
Yes, sir.
Yeah.
Apart from IC, which standards do it have? So there is one more question. So yeah,
Okay.
apart from IC for electrotechnical, yeah, so we have NEMA standard. So electrotechnical IC and electrotechnical NEMA. So we have these two standards. So actually the component in both the library will be same, but only the difference of the standards. Okay. Okay, we can conclude the session, I think.
Mm, no, there are some more questions like reports. Yeah, you can create the reports here.
Reports. Yeah. From the suppose this is a schematic. So in the project only, new project only, I think on new document. New, yeah. So we have spreadsheet report. So you can create a report as per your, suppose this is an example for the, suppose BOM. I will create for the BOM. Suppose that is an electrical circuit, so we can create a report for different wiring, different. So in this BOM nothing is there because we don't have component belongs to that, so we need to have that type of compatibility on that project. Suppose for this one I will take one of the component, or on the electrotechnical diagram I will take the component from the this one. Okay, so I will take this one, so it will be directly give us that report in the reports. So this part number and the atom identifier will, yeah, here you can see this component and its part number, description, everything can be visible over here, and it is giving us that report. These components are available in this series. So again, we have for the reports also, as we seen, we have the spreadsheet report, BOM purchase list for the, suppose it is a connector list, if it is electrotechnical, if you are using a PLC, different manufacturer, so we have this one. So for this we can create, as well as we can assign the fields. Suppose if you don't want a item identifier, and apart from this we want a comment from that component. Suppose this is a component and it has some other specification also. So if you want this component name or this comment in your report, so that is also possible to have it in the report.
Okay, so there is one last question. Do we get any certificate? Yeah, you will receive the certificate after the webinar. Okay, you will receive it. Okay, so if there are no more questions, so we can conclude this webinar.
Yeah.
So Venkat Prasad, you want to say something?
Yes, sir.
Okay, so we are done with the webinar.
Yes, sir. Right. So hope everyone had a great session today. Thank you, Ms. Kalyani, for the wonderful session today. So also thank you to the entire FAMIC team. So we have next webinar on Wednesday on different topic. So I request everyone to do register for the session. If you are already registered, the invite will be, the joining link will be sent soon. Yeah, thank you all. Have a great day.
Thank you very much.